Hi, I'm Damon with Learning Blade, and I'm going to show you how to use our traffic collision activity from our Mission Challenge resources to promote exciting STEM careers to your students. In the Learning Blade Traffic Congestion Mission, students will learn about the challenges that city planners face when designing safe and efficient traffic systems. In this Mission Challenge activity, students will simulate various collisions with toy cars and measure the changes in forces produced by the changes in the collision variables. This will introduce them to some of the ways automotive and traffic engineers plan roadways and traffic intersections. Now let's begin our activity. For this activity, you're going to need several materials. You're going to need a wooden board about 2 feet long. You're going to need some toy cars. We're going to need a book or a box so that we can lift up one end of our ramp. We're going to need a tape measure or a ruler. We're also going to need a stopwatch or a timer app on your phone. We're going to need a scale to measure the mass. And then we're going to need some tape or rubber bands to add mass to the cars. And the mass we'll be using are just pennies. You could also use washers. So let's get started. Now we've got everything outlined here in our worksheets. We've even got our worksheets that are going to help us keep track of all of our measurements. So we'll keep that over there. And then the instructions tell us how to begin and set everything up. Basically what we're going to do is we're going to take a board like this, and we'll take a box or a book or something like that, and we're going to put it under one end of our ramp. Another thing we're going to do is, since we're going to be rolling a car down this ramp, is I'm going to go ahead and put a piece of tape here, and I'm going to put a mark here so that way we always start our car in the same spot. Now, something else that we're going to do here is I'm going to place some boxes on either side, and this is going to guide our car so that when it's rolling down the ramp, it always comes off the ramp in the same spot. You could do this with books. I've just got some thin boxes here, but either will work. Basically anything that'll just guide your car down the ramp. Now in our first observation, what we're going to do is we're going to measure our car. So we'll turn on our scale, and then we'll measure the mass. And so we've got 39 grams. So I would record that. I would also do measurements of my ramp because I want to calculate the slope. So I would measure that, and then I would record that on my worksheet as well. Once I've got the mass of my car, I'm going to put it at the spot that I've marked, and I'm going to let it roll down the ramp. Okay, so that's what we would do. We would also get our smartphone out, and we would want to time this. So we'll start again right there. I would have my smartphone out, and it would time that. Now, one thing we're going to do is we would have this probably set up on a floor where we had more room, but we would want our car to roll down the ramp, and then we would measure how far it goes. So we would measure our dimensions of our ramp, but we would also measure from the back of the car to the ramp, and we would record all of that on our worksheet. We would also have the time, so another student would be calculating or measuring the time from when it started to when it stopped moving, and we would record that on our worksheet as well. So the purpose of doing this first set of observations is to basically understand, well, okay, how far does this car go? How fast does this car go when it's got its base mass? Then what we would do in observation number 2 is we would take another car and we would place it along the path of car number 1. So then we would roll this down the ramp so that they impact. And then what we would do is we would measure the distance from where this car, how far did it travel after it hit, how far did this car travel as well. And we're recording everything on our worksheet. We can also put a piece of tape down so that we know, okay, here's where the car started. And that helps us make that measurement to this blue car of how far it got pushed away. We're also going to run this experiment several times so that we take an average and we can work out any imperfections in how we're doing things. Maybe the car didn't hit each other exactly in the right spot. But again, I would measure and I would see what my distance is between where the car was and where it went and where did my first car stop. Now, what we do in the third observation is we're going to make some changes to things. In one sense, we could do where we change the slope of our ramp. So I'd take my box there. First, I would move this car out of the way, and I would roll this. And again, we're going to have somebody timing it. So now it moves much faster, and it would shoot on down the hallway or wherever you're running this, and you would be timing it. You would also measure the distance that it traveled once it left the ramp. Then we would put a car in front of it, and we would roll it down the ramp again. All right, and so we would do those different measurements. Another thing we can do is we can make changes to the mass. So maybe we're going to turn our slope back to what it was in our first observations. And we'll place a car there. And we're going to add some mass. And this is where we would use a little bit of tape. So we're going to put some coins on here. All right, so we've got our load. Another thing we're going to do is we're going to measure that mass. See what it is now. Okay, so our mass has gone up, good. And again, we would make all of our measurements, keep track of those here. And so now we would roll this down and see what the difference is when it impacts the car. So you can see this has now traveled much further than it did in the first series of observations. Both cars have. So what you can do is by changing the mass, you could roll this without a collision and you could see what the percentage change was. And then you could make calculations and say, well, okay, based on the percentage change in speed, here's where I think the percentage change will be in terms of how far the car gets knocked in the collision. And again, this is at the first slope. If I change my slope back to that, and there you go. So, and I could run that experiment several times and again do an average. So what we're doing here is we're giving students a chance to make changes to the experiment by adding mass or changing the slope of our ramp. And then they're going to be able to predict, well, what are the impact of those changes when we do our collision. And so this is a really fun experiment that you can run that, again, illustrates some of the challenges that traffic engineers and automotive engineers have to face when they're designing roadways and intersections. We also have some discussion questions at the end of the sheet here where we go through some of the questions here that really gets students thinking more about some of these issues that are surrounded with traffic safety or collisions and intersections, and maybe you would redesign the intersection so that it wasn't coming down a hill because then cars would go slower and it would lessen the chance of unsafe accidents. So that's an example of how you can run this experiment and do our traffic collision experiment. In addition to this project, you can find other Mission Challenge activities in the resources section of Learning Blade. Thank you for watching, and be sure to check out other videos in this series.